All right, good morning and happy Sunday. It is 5:30 in the AM and it's time to shine. We're going to be doing contest 328 from yesterday. Let me share my screen here real quick. Alrighty, here we go. Time to shine. Open these guys up. Boom, boom, boom. Okay. Absolute difference between elegant sum and digit sum. Okay. Let's see, it's 539. Total, let's see, let's call this one sum, the sum of A, and then total 0, return absolute difference between S and T, and then for X in A, while X, T plus equals X modulus 10, X divided by equals 10. Okay, something like that. Should be 9 and 0. Looks good. Okay, nothing too fancy. 9:39 to 9 or 5:39. Yeah, less than 1 minute. That's cool. Okay, yeah, nothing too fancy. So that looks good, right? Reduce it. A few solutions. Let S be the sum of each value X of the input array A, and let T S, right, be the sum of each digit of each value X of the input array A. Alrighty, we'll return our absolute difference. Kotlin, JavaScript, oops, JavaScript, Python 3, Rust, C++. Okay. Okay, so auto S equals accumulate A dot begin, A dot end, 0. T equals 0 for auto X A. And T plus equals X modulus 10. Oops, hold on. While X divided by equals 10, and then return absolute difference between S and T. Nothing too fancy. Keep it super simple. Okay. JavaScript. Let S equals A dot reduce A B. B 0, return at the abs, S minus T, or oops, the X of A, while X T plus equals at the floor. Oh yeah, look, oops, hold on. This is X modulus 10, and the X equals the floor of X divided by 10. Right? Yeah, that looks good. Kotlin. Dot sum. Then 0. T at the end here, and then for x in A, while x exceeds 0. Make a linter line up here. T plus equals x modulus 10, x divided by equals 10. Whoa. It has some intermediary y. Y modulus 10, y equals 10. Looks good. Okay, and rust, and then move on. Let s equals a dot sum. Does that work? I don't know if there's a sum function or not. See if this compiles. Sum does. Oh, a dot iter dot sum. Does that work? Yeah, that works. Okay. Let mute t equals 0. Abs. Let's see. S minus t dot abs. For x in A. While x exceeds 0. Modulus 10, x divided by equals 10. Not infer type. I32. Really? Type annotation is needed. Oh, x is immutable. Okay. That mute y equals x. Just stick y in here. Similar to Kotlin, it's a little bit more strict. And then I don't think we need this guy. Do we? Looks good. Okay, it's accepted. All right, that's good. Let s be the sum of each value x of the input array, and let t be the sum of each digit of each value x of the input array. All right, looks good. Post that. Nothing too fancy. Okay, Q1 is done, and we have 1 hour, 21 minutes left. Q2. 1 hour, 21 minutes left in the contest. $500 by 500. It's 10,000. 10,000 queries. And it's 500 times 500 is 25. Does that look right? 500 times 500. Hold on. Is that right? 500 times 500. Oh, it is 250,000. Holy cow. Okay. 250,000. Oh, queries. Oh, I see. Okay. So they're all zeros initially. Okay, so we add one to every element. Top left and bottom right. 110. Oh, this is that one. Okay, so 1 1 to 2 2. 1 1 to 2 2. Okay, and then 0 0 to 1 1. Okay, that makes sense. Okay, so it's inclusive. Okay, so plus ones and negative ones then as relative. And then flood fill. One. -1. Track, I guess, relative -1 +1 for each query, then flood fill answer. So how's this going to work out? One here, and then -1 there, -1 there. One, -1, -1 and 2, 1 plus. Okay, yeah, so thinking offhand, we'll do something like this. Okay, so we got n equals 3, 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. It's all zeros initially. Oops. I think I do want to just create this relative thing as n plus 1. Okay, so then the queries are 1, 1, 2, 2, 0, 0, 1, 1. 1, 1 to 2, 2. It's 1, 1 plus 1. 2, 2. Go -1 here. -1. Kind of throws everything off. So then when I calculate these things, I can say this cell is the top left, left, and above currents relation. For each ij cell equals above, left, above, and left, which ends up being above, left, above, this left. So if we negate this out, 1, 1. Maybe we don't want above and to left. Maybe we just want above and left. Above and left. How do we have to negate this thing out eventually? 1, 1 to 2, 2 inclusive. So and negate this guy. And negate that guy. So when we flood fill this thing, these will all be ones. It'll get back to 0. 3, 0, 1, 2. 0, 1, 2. And plus 1 be this many. Suppose we don't have to calculate it for that. Okay, so something like this maybe. 1, 1 to 2, 2. And then when we process 0, 0 to 1, 1, which is the next query, right? Then 0, 0 to 1, 1. So 0, 0, boom, to 1, 1. So it'll be 1 plus. This be 2. So how's this guy going to be 2? This guy's 1. This one will be easy to do on paper. I'm going to take a break or just write it down on a piece of paper real quick. See, 2536. Increment submatrices by 1. Yeah, so and the gist of it is we'll have relative offsets and then make an absolute sum. Okay, let me mess around with this and then find the recurrence relation. Right, this isn't quite right. Left. Okay, so they don't have to be squares. They could be rectangles. So we did 0, 0. Zero, 0 to 1, 2, be a rectangle. 0, 0, 1, 2. Yeah, we'll be new into set zeros after this. Two, 1, 1, 1. How many overlaps there are? Two, 2, 3. I might need some more coffee for this one. So I basically need to find out how I can make these relative offsets and then come up with an absolute sum based on relative offsets, right? Otherwise it's going to TLE. All right, so what is the recurrence relation for 1, 1? How can I say the relative thing is 1 and the negative 1 here, negative 1 here, negative 1 there. So you stop adding at the end. What if we, let me just play some inputs. 1, 1, 1, 1, 1, 1. Three, 2, 2, 2, 1, 1. It's like, how do we have this top left propagate down to the bottom right and overlap? And how do you cancel it out to come back to 0 after you're at the bottom right? Man, this one's tricky. This is one of the ones that have to go slow, I think, to go fast. Negative 1, negative 1. track them as intervals, maybe. I don't know. Keep it super simple. I'm pretty sure there's got to be a recurrence relation I can find, right? And come on, they're definitely overlapping, right? Overlapping relative offsets. +1, -1. This plus that minus that. This plus that minus that. That. This plus that minus that. What do you zero it out there? 1, 1. This to be 0. This plus that minus that. So that minus that. Could be. This plus that minus that. Okay, so above plus left minus above plus left. Above and to the left, right? So minus dp sub I minus 1, g minus 1 above and to the left. Does that work out? I think so. Let me put a -1 here. dp sub I itself plus above to the left, right? So dp sub ij is the relative. So plus equals that is 0. This plus that minus that is 0. This plus that minus that is -1. Okay, so we want that to be +1 then. +1 to the top left, +1 to the bottom right, -1 on the top right, -1 on the bottom left. Yeah, okay, I think it works okay. So hold on, so this would be +1 here. 1, 1 to 2, 2, so flood fill. Or to flood fill this thing like that. This plus that minus this is 1. 1 plus 0 minus 1 is 1. Zero plus 1 is 1. Minus 0. All right, so that turns out to 0. This plus this minus that is 1. This plus this minus that is 1. This plus that minus that is 0. Plus this plus that minus that is 0. 1 plus 1 minus 1 is 0. Okay, so I think that works out. Let's see what happens. Queries, an array of queries, and we'll just do Q. How about queries? Okay, so DP will be all zeros. I want to do n plus 1 for, hold on. Score in range n plus 1. And then for so IJ will be the top left corner, and UV will be the bottom right corner. You want to create an array. Or no, DP will be our answer, right? So we'll truncate DP to the first in rows name columns. Here, let's just do this. Ugly, but whatever. 0 times n or oops, range n range j and range n a sub I sub j goes dp sub I sub j. Just copy it over right down. Keep it super simple for now. We'll clean it up later. Okay, so dp sub I sub j plus equals 1. dp sub ith row vth column plus 1 minus equals 1 dp sub right the bottom load the jth column so this is top left, top right, inclusive, non-inclusive. This guy is bottom left, non-inclusive. U. Okay, and then dp sub u plus 1, v plus 1 plus equals 1. So this is the bottom right. Bottom right, non-inclusive. Okay. And then we'll just add them all up, right? So for basically this guy, go through each of these. dp sub I sub j plus equals of, if it's possible, if there is an above, dp sub I minus 1 j is above, if you have a left, oops, left, if there's an above and to the left, minus equals dp sub I minus 1 j minus 1. Okay, let's see what happens. List index out of range, top left and inclusive. IJ. Really? Oh, oops. Come on. Let's go LeetCode. Out of range. Oh, same thing. Too many brackets. Does that look right? 110. No. 121. 122 is not right. Okay, so the first query looks it was added up okay, but then the second query we're not subtracting enough. Oh, oops, hold on. Subtract that. Ooh, that looks right. Okay, cool. Yeah, this is great. I'm totally stoked. I think this is totally legit. Big money, no whammies. Yes. All right. That one was tough. Okay. So 43 minutes. Let's see, 43 minutes left. 0 hours, 43 minutes remaining. So that took 17, 38 minutes. Yay. 38 minutes, 17 plus 21. Nice. Okay, cool. Yeah, so we can clean this up a little bit, but that was the correct recurrence relation of overlapping queries of relative offsets transformed once into absolute offsets. Okay, so let's clean this up. TP. Yeah, let's do this. Turn DP at the end here, and then if v plus 1 is less than n, I'll do that. If u plus 1 is less than n, I could do this. And then if u plus 1 is less than n and v plus 1 is less than n, then we can do this. Whoa. Oh, okay, we're gonna go through them once as well. Okay, so for I in range in, for j in range in, TP sub I sub j plus equals, let's do this. Above equals TP sub I minus 1j if it's in range. We call up, right? Up, left, and diagonal. TP sub I sub j minus 1 if j minus 1 is in range, and then dp sub I minus 1, j minus 1 if I minus 1 and j minus 1 are in the bounds. Above plus left minus the diagonal. Doesn't look right. No, that's not right. Okay, hold on. Oops. This guy should be in, and this guy should be in as well. Range in, okay. 1, 2, 1, 1, 0, 1. No, that's not right. 1, 0, 1, 2, 1. What did I do? Oh, it's minus. Wait. Minus. Plus above. TP sub ij. Above, left. Above and to the left. And to the left. What am I doing wrong here? the heck? Should be a 1, right? 0, 1, 1. Bottom right is not correct. You should. Suppose it. What? Plus that minus that. Step 1. What? Oh, what? In. Okay. Oh, super simple type. Okay. All right. So, how do I clean this up? Offset the DP matrix by 1. We could just surround it. Let's see if that looks cleaner. Set DP matrix by 1 on all sides, then return 1 to n, the inside portion, plus 2 surrounded on all sides. DP matrix will be offset by 1. Offset by 1. P matrix offset by 1. Up, left, diagonal. One, two, and inclusive. And A equals 0 times n, or underscore range n. A sub I minus 1, j minus 1, this is offset by 1, equals dp sub I sub j. Right, okay, something like that. Offset by 1, looks good. That way we don't have to do all the bounds checks. And take the inner portion of it. Okay. That much time. We have 30 minutes left. Okay, so we should move on. I'll do this in the other languages here real quick and then call it a day. Maybe we'll just do this in the other languages. um, hmm. What the heck, no. It seemed like a pretty decent solution. Nothing to the left. It's a decent solution. It's okay. Yes, yeah. Up, left, up and to the left. Above left, above and to the left. It's okay. Relative offsets, right? Plus one or minus one. Breach. Or tracking each queries. Up, left, right, bottom left. I guess each query is, I don't know. I guess. Right. Then accumulate absolute via the recurrence relation. dp sub I sub j, this equals dp sub I minus 1 j above, left, above and to the left. Ij cell absolute value is self plus above is current cell plus above cell plus I guess the cell plus above cell plus left cell minus above and to the left cell. Absolute sum. That's just how it works out on a piece of paper. Ij cell value with ij cell plus above cell plus left. So cell ij plus cell above plus cell to the left minus above minus the cell above and to the left. All right, whatever. And write it down on a piece of paper if you don't believe me, right? So, that's what I did. JavaScript 3, Rust, C++. Okay. It's kind of ugly, but whatever. It doesn't have to be perfect. It's good enough, right? each query is on IJUV. Let's do this. Let's add one onto each of these. Tuple. Left inclusive. Top right, not inclusive. Bottom left, not inclusive. Bottom right, not inclusive. Let's see, DP matrix offset +1. Since it's offset to inclusive. One to n inclusive. Set by 1. Okay, and then this guy will be above. To the left, minus above, and to the left. Okay, something like that. Looks good. Okay, it's cool. Okay. And queries. DP array. That's 1 or 2. So we're going to surround all sides. We don't have to check the bounds. Each row will be an array. N plus 2 filled with zeros. Let A equals array of n. Each row is mapped to an array of size n. It's filled with zeros as well. Might as well initialize it. Trinity at the end here. Okay, so for let IJUB of queries I plus this j plus this u plus this v. DP matrix offset by 1. DP sub I sub j plus equals 1. Top left inclusive. Let's see, I v plus 1. Top right non-inclusive. This one's j. Bottom left non-inclusive. This one v plus 1. Bottom right non-inclusive. Oops. Okay, go for that, and then let's go to in. It's offset by 1 to n inclusive. dp sub I sub j equals a recurrence relation, and the a sub I minus 1 sub j minus 1, since it's offset by 1, is dp sub I sub j. Oops, hold on. Oh, actually, let's just do this. Shorthand, this guy equals that guy, equals of left minus above and to the left. Okay, something like that. Uh-oh, that is not right. Oh, plus equals. Looks good. Okay, it's cool. Okay, JavaScript, Kotlin and Rust. Next, okay, so TP equals an array of size plus 2, so we can surround each of the int arrays of size equals 2, initialized to 0. A array of n size n of zeros. At the end here, for ij ub queries, oops, in queries equals okay, let's do this actually. Queries equals queries map it plus 1. No, that doesn't work, right? Map. Add 1 to each of these things. Row in the array. Each of these. Okay, that looks good. TP matrix offset by plus 1. Left inclusive. Right, non-inclusive. Bottom left, non-inclusive. Bottom right, non-inclusive. Okay. There's that, and then line 1 till n inclusive. J and 1 to n inclusive. dp sub I sub j plus equals. And then a sub I minus 1 so j minus 1 since it's offset by 1. dp sub I sub j. And then this guy's above to the left minus above and to the left. Okay, something like that. Looks good. It's cool. Okay, do rest and then move on. How much time do we have left? Oh, we got 11 minutes left. Holy cow. Okay. Q2 took all my time. It is what it is, I guess. Type. Okay, queries. BI. Okay, so let unit dp equals vector of size n plus 2, which is a vector of size n plus 2 with the value 0. Let unit A is a vector of size n filled with the vector size n by 0. I'm trying to get the end here. Okay, so for u in queries, let I j u v equals query 0, query sub 1, query sub 2, query sub 3. DP matrix offset plus 1. DP sub I sub j plus 1. Top left inclusive. Let's see. I need to make it a U size. That's U size. U size, U size, U size. This one, top right, non-inclusive. This one's a J. Bottom left, non-inclusive. Right, non-inclusive. Okay, then for I and 0 until n non-inclusive, or j and so 1 to n inclusive actually is what I want. 1 to n inclusive. TP sub I sub j plus equals above to the left minus above and to the left. A sub I minus 1, J minus 1 equals 2P sub I sub J. Turn A at the end. Oh. Such a 1 of 7 possible tokens. Vector macro. Expected U size. N equals N is U size. Uh-oh. U size found vector. Oh, it's the value then the size. Value then the size. Okay, value then the size. Value size value then the size. Looks good. Yay. Okay, I think that's about all she wrote for today. I'll save Q3 and Q4 for later. The kids are awake, so I'm gonna go spend some time with them and play with them. That's pretty cool, right? DPV to relative offsets, IA +1, -1 for tracking each query's top left, top right, bottom left, and bottom right bounds. Relative, right? So relative. And then you can accumulate absolute offsets. Like quadratic time. Yeah, that's good. That's a cheap answer, right? So let DPP relative offsets, IA +1 or -1 for tracking each query's top left, top right, bottom left, and bottom right bounds in O of 1 time per query. The top left cell IJ and bottom left, bottom right cell UB. Then we can accumulate absolute offsets via the recurrence relation, right? Above to the left, above and to the left for each IJ cell's absolute sum is cell IJ plus cell above go to the left when I cell above to the left. Whatever. Okay. 3 minutes and yeah, it's about time. I don't want to look at Q3 or Q4 yet. Might as well save those for when I'm fresh. And that was a tough one for being 4. I wonder what other folks posted. Prefix sum, sweep line. Well, this is a lot more simple. Prefix sum. It's not that simple. Oh, nice. Yeah, it's not too shabby. Oh, NumPy does it for you. NumPy. Butcher box. That's kind of what I wrote. Yeah. Holy cow. Okay, yeah, my solution is not too shabby. Yeah, it could be simplified, but not too shabby. I'll save Q3 and Q4 for later. Catch you all next time.